Today, we're going to dig into a really fascinating geographical puzzle. It's all about how a single mountain range can act like a powerful and kind of weird weather-making machine.
So, have you ever wondered about this? I mean, it seems almost impossible, doesn't it? How can you have these two completely different ecosystems living right next to each other, separated by nothing more than a mountain peak? Well, the answer lies in the incredible journey of the wind.
Just look at this contrast. On one side, you've got this vibrant, wet, totally green landscape, and on the other, a dry, barren desert. Now remember, this isn't two different continents we're looking at. This is the two faces of the exact same mountain. So what on earth is going on here?
All right, let's get into it. To really understand this, we're going to follow the adventure of a single character, if you will, a packet of air. We're going to track its entire journey all the way from the ocean, up one side of a mountain, and right down the other.
Our story starts out over the warm waters of the Indian Ocean. There's this huge mass of air moving inland, and it's just loaded with invisible water vapor. It's warm, it's moist, and you know what? It's heading straight for a massive obstacle, a mountain range.
And that brings us to the first part of its journey, the climb. This is where all the rain-making magic happens, and it happens specifically on what's called the windward side.
So what exactly is the windward side? It's really simple. It's just the side of the mountain that's facing the oncoming wind. Think of it as the mountain's front line, its first point of contact with the weather.
So let's break this down. First, that moist air hits the mountain and has nowhere to go but up. As it rises, the air pressure drops, which causes the air to expand and get really cold. You know, it's kind of like when you spray a can of compressed air and the can gets frosty. Same idea. Now, this much cooler air can't hold on to its moisture anymore. It hits what's called the dew point, and all that water vapor condenses into clouds. And eventually, those clouds get so full, they just have to release all that moisture as rain.
And the result of all this is a special kind of mountain-made rain called orographic rainfall. This is the very reason why places like the eastern slopes of the Drakensberg Mountains are so incredibly lush and green. They're just constantly being watered by this amazing natural machine.
But wait, our little air packet's journey isn't over yet. After dumping all its rain, it makes its way over the mountain peak and starts to go down the other side. And this is where things take a really dramatic turn. This is where the desert gets made.
Now, this side of the mountain also has a name, the leeward side. It's the side that's sheltered from the wind. So if the windward side is the front of the mountain, you can think of the leeward side as the back.
At this point, our air packet is completely transformed. I mean, it's lost pretty much all of its water. So as this super dry air begins to sink down the leeward side, a process called subsidence, a whole new set of physical rules takes over.
So as the air sinks, the air pressure around it increases, basically squeezing the air molecules back together. This compression makes the air heat up, and it heats up fast. This process is called adiabatic heating, and it's the exact opposite of what happened on the way up the mountain. I just love this quote from our source material because it captures it perfectly. The air has been, and I quote, literally robbed of moisture by the mountain barrier. It came in wet, and it left completely dry.
Now here's the kicker. This sinking air doesn't just not produce rain. Because it's now so warm and dry, it actually gets, well, thirsty. It starts sucking up any moisture it can find from the ground and the plants below, creating these intensely dry conditions. This is exactly why a region like the Karoo, which sits right behind the Great Escarpment, is a desert.
So let's step back for a second and see how all of this comes together into one single powerful idea, the mountain's rain shadow.
Okay, so check out this side by side. On the windward side, air rises, pressure drops, it gets cold, and you get rain. Simple. On the leeward side, the air sinks, the pressure goes up, it gets hot, and you get a dry shadow. You see? Two completely opposite processes happening on one single mountain. And this whole phenomenon has a name, the rain shadow effect. This is the big why behind those two completely different worlds we saw at the very beginning. The mountain literally casts a shadow where rain just can't fall. So, the next time you see a mountain range, think about this incredible invisible engine that's hard at work. It really makes you wonder, right? What other powerful invisible forces are out there constantly shaping the world we see, hiding in plain sight?